So I don't have much time, but I will just pause the recording and finish when I come back if I don't finish it. So we got optimal account balancing. We got some transactions from person to person and the amount returned. Minimum number of transactions required to settle the debt. That's weird. Just 8 transactions with 12 people. That is a weird ass question. So wait. So so one needs to give $10. So no, you just need to give money to someone. That's weird. Okay. That's a tough one. Might go for medium actually today because this is tough, bro. This is premium and 100,000 people. There's no way Leetcode made tens of millions of dollars, bro. There is no way. I mean, that's number of submissions, so multiple per person. Yeah, whatever. Area of transactions. Return minimum number of transactions required to settle the debt. Okay, so this guy wants 10. This guy wants so this guy wants, well, okay, we can get the differences. Okay, so what you want is to get back the amount you sent. So you can calculate difference between what you have and what you want. But this 8 is extremely suspicious, bro. That is extremely suspicious. I don't like that the constraint is 8. Because okay, so I would let's say I calculate what have and want. So I mean, this is tough. They don't even give the number of people or anything. That is stupid. Want, have, auto transaction, in transactions, and now want transaction 0, transaction 2, and have transaction 1, transaction 2. So basically T0 is who is sending, so he wants it back. This, and this guy which gets it does have it. And what we are interested in is vector int. So we have some guys which will be sending money. Those are that have more than they want. So to send, and then we have to receive. If want I is over have I, meaning this guy is missing some money, then to receive push back want I have I, else if have I, so he has more than he wants, it needs to go to someone else, so he can send that money. To send have minus. Okay, so once we're done with this, now we need to so would it be worth it? We clearly want to put the largest amount. To the largest guy, so maybe I want a set of I don't want to do priority queue, that's all, but this is max queue, so I want to have well, let's say I have 5 and 2, and then I have 4 and 3, and now what is it better to give to? Well, obviously you want to split it the least, so the problem is I'm doing a possibly n log n solution, and I'm possibly doing n log n solution, and this has n equal to 12. So probably I am missing something. We will see. But with 8 transactions, bruh. Do I really want to order by this? I'm not sure. I guess. I mean, because let's pick the largest transaction, and now is it worth it to put it to the largest collector or to receive guy? Well, if it wouldn't, we would put something smaller there. What could cause it? Well, if that would still be larger than the sum that is owed, that would make the transaction number same, but the larger to send might be split into more later, or at least the same amount as the smaller value, which sounds extremely confusing probably to anyone who is listening. That was one person who is listening except for me, but who cares? So basically that's what I want to do. Trans, and now we go while not to send empty. What do we want to do? Well, send is to send top, to send pop, receive to receive top to receive pop, and now transaction plus plus, and then what do we want to do? If send is smaller than or equal to receive, no, like this. So if send is smaller than that, well then receive push to receive push receive minus send, so the remaining amount that he is still owed, and we basically just used all the money, so we don't care. And then else, well, we paid off everything, so we are not going to push, we are not pushing anything to receive. If sent over, else if sent, if they are the same, we don't push anything. I'm not sure this works because seems like absolutely stupid solution which would not work for any reason. Okay, so output is 6. So 1 pays 5, 8. 8 pays 9, 8. 2 pays 3, 9. And what the hell? So maybe that's not the best approach. So maybe I can try each subset of if I try, basically you just want to reverse some transactions, not all. And I think you don't need to do, okay, so we are trying to reverse some of these transactions, some subset of them, maybe the whole, all of them, maybe one of them, but some subset. And then we want to do, after we have computed this doesn't work, so for in mask constant t transactions size mask 1 to t mask plus plus, and for each of them we do a subset of people who are gonna be sending int people mask, at least one person is gonna be sending p mask plus plus, I guess. So int actual p mask for int bit plus plus, so we get the transactions we are using. So person to person, I need to build some sort of a graph. Vector pair, not really. Vector if mask bit and 1, then G, so we need to pay it back. So G transactions bit 1 push back transactions bit 0, and then actual int from, that's 2, so from is 0, from actual p mask or with 1 to from or 1 to 2. That's the mask of people, and we build the graph. And if actual p mask doesn't equal p mask, then continue. I mean, only people involved in the transactions should do something. Because should anyone sending the money? No, just the people who receive the money. So this is the receive mask or send mask, send mask, send mask, and then we have that's people mask, and send mask is off. Well, it needs to be reversed, so the people who were sent money to will be okay. And then somehow I have to try to do it in lowest amount of transactions possible. I mean, if there is a cycle, I'm kind of cooked, but okay, so now that I have that graph, which I don't know if helps with anything, because there could be like this, but also this and this. So he should send to everyone, but what if someone is sending to him? Or he is sending to someone also, so someone should return his, so he might not even have enough money to send the other guys. I'm not sure. So we need to just, based on the graph, check if it's resolvable with those transactions, and if it is, then the answer then we can update the answer with number of set bits in transactions, and that's it. Sur transcend 0, sur transcend. Okay, now I gotta go. I'm pausing this. Okay, I am back, and I'm not sure why is it lagged, but okay. For some reason it doesn't even work in this. What? Okay, so basically I'm saying that I should do all of these transactions. So I'm just interested in whether I don't have to do a graph. If this is true, want, and now I want to do because if I say that I reverse these transactions 0 to 1 gives 10, 1 to 0 1, 1 to 2 gives 5, and 2 to 0 gives 5. 10 bucks, and that guy moved 5 bucks, and this guy moves, so he needs 4 bucks. And person 2 has everything, so I don't actually want to do this. Amount transactions bit 2. And what I want to do is have do I really want to reverse all of them? Because if there is a cycle, no, I don't want to do the entire transaction, because if we do back and forth, then I only want, so let's say one paid so 1 cent to do this amount. So what I want to do is send that amount back to 1. Or do I want to send that amount to, I want to reverse the operation, but maybe I don't even need to do that. When is that the case? Well, if I do, if want from over have from, then we want to do have from plus equals delta. And delta is want from minus have from, and have plus equals delta, and have to minus equals delta, and after the fact if ans minus 1, well, the number of, okay, ans min ans sur trans count but at least t, so we just reverse all of them, return answer, and last thing we have to check is bool awk true if want I doesn't equal from I, want have awk false break. So if awk and this, let's run it. Actual mask, actual p mask, okay, send mask now, whatever. submissions. I want the test case from there. Use test case. Boom, boom, boom. Not sure. Oh, it gave the correct answer, so it might work. Wrong. What? Expected 0? Okay. Well, didn't think of that. Okay. Let's see. Now it will say 22 out of 36 passed. 23. Oh wow, that is awesome. What? Output 3 expected to. Well, 0 pays $2. 1 pays to 1 pays to $1, and 1 pays free $1. So if only well, you gotta select which people are paying or which have to be paid to. And which are gonna send the money. I'm not sure. I think I have to read a hint which does not exist. Oh my days, that is awesome. I think I'm overthinking it. Well, then these guys pay here. So what I want to do is well, what will be the brute force? We select the guys who pay, and then we select who they gonna pay. Well, obviously only the ones that have more, so that can be only half of the people. So we select, and then obviously all of them want to pay, so we go through subsets of how many transactions can we settle that. That's weird because, wait, what's this case? Really, with 2 transactions? Well, you gotta pay $5, but it also has to pay that, so maybe you could pay 5 to each, I guess. This is a cycle for 9, and then something. I'm not sure how to solve this with my method, because my method only checks the transacted guys. So I mean, I could add fake transactions, but that's way too many people. Well, there is up to 8 transactions, so there cannot be that many. What? 4 people can pay 4 people, so well, you select a subset of people that have more, or everyone that has more, and you have to pay everyone that has less. but then this case didn't work. 4 to 3, 2 to 3. I'm not sure. This is tough. Minimum number of transactions to settle the debt. I mean, you could try to, if there are cycles, that's kind of rough, but it's 8 and 12. I'm not sure how to solve this in the general case, so that's tough. And I have to eat lunch and do a bunch of stuff for school, which I should have done already, but whatever. I need to take it from some angle, like what is the thing I should iterate over. Like, some people will get the money, some people will send the money. I don't understand why my initial method didn't work, to be honest. Let's use the code. Well, it says 6 transactions for this. And why would you even assume that? 1, 2, 3, what? Really? What's to receive if I want more than I have? Well, well, 5, no, which ones want? 1, 2, and 4. So 1, 2, and 4 want some money, and 3 and 5 are willing to send it. So first, I'm not sure why this is 8 and 1, to be honest, because to send is have more than they want. Wait, why am I doing a mean queue? I am so stupid. I was doing a mean queue, bro. Maybe now it will work. I don't know. Probably not. Still doesn't work. So output 4. Why do you think 4 is necessary for this? So 0, 1, and 3 should get some money. and 4 and 2 have some money to send. So first you take 8 and 5 and you send 5 there. Oh, that doesn't work. So okay, that's the problem. Fair enough. So for each person sends money to some people in there. Now question is, like, everyone who has money will have to send it to someone. Question is how you want to split it. Because in this case you have a, what's the answer here? Once you can skip these, you can skip all here. These you can do in 2. This you can do in 1 transaction, really. Okay, this is easier to grab. So you send $5 here and $5 here. So you can move money any way you want, and you just want to match. You just want to go from this to this. How to solve that? Great question. Well, you pick the subset of people that are gonna be sending anything, and then you pick the subset of people who are gonna receive something, and you just wanna match them somehow. Won't have how you wanna get that money from those guys? Because everyone gets their money from someone. So let's say that because with 8 transactions I guess there could be at most not even 8 people who are gonna need money, at most 6 people who are gonna need money and 6 that are gonna have more money. So for each 6 of them it's 2 to 6. So let's say these people, so if I want more than I have, then I need to pick a subset of people who have less money than me to give it to me. So I want to split the more less for person if want more than half, then he has less than he wants. If want have more, great. I mean, if I just say that what people pay me, like in this case, let's say I can get paid by these people and this guy by this person, or reverse. First is want. Whatever. CPP. Yeah, first is want. So which subset of people are you gonna be paying? That varies. Here I have to get paid by this and this guy by this. Here nothing. So question is, technically everyone, but let's say I go through subsets of subsets of less and subsets of more, and be like maybe he will not have enough money to send. Nah, I cannot. I have to get something. Recursion logical thinking. I mean, person owes others 10. Well, assuming 0 to current I has been settled, for debt of current I, any of these such that can settle it. What are you saying? Next account to balance current ID. So state function. What the hell? Get transactions. You make that map. So this guy gets a plus, this guy gets a minus. that size. That, and you go through values, and that of you just make it into integers, and you read what is this get mean transfers after. It's not even called anywhere. What do you mean? That's build that array. Mean transfers calls build that array. Okay, and then you get mean transfers after that. Skip, and then if we are end, so mean transactions. Well, this guy gets money from me. Okay, that's a nice trick, but so I get the amount from so that means current ID is less. But this is written in Mongolian, bro. Let's show DP. Who end up not owing or owed. Okay. Find max number of sets where each set has a sum of 0. Interesting. So I can get 2 sets. And then 3 minus 2. Interesting idea. So let's think about that. So CPP, this is not the CPP solution, bruh. Vector int that. So he has this amount of money, but okay, so he has negative that. Okay, now we want to do the subset. So to go for each mask and how you want to iterate over those masks. So let's say we have these whole people, then you can do free to n, right? Oh, I already see editorial. Why did it show me editorial now? Net balance of each person. Backtracking. This is just stolen from here in factorial. That's slow dynamic programming. Okay. So let's say we have a maximum number of subgroups. Microsoft on-site. I just cannot think about this. Like, well, okay, if in some group they have sum of 0, then you can settle them in n-1. And what if you can settle them in n-1? I don't know. Well, let's say we find here two groups, or in some other inputs we have like this is one group, two groups, one group, three groups. This can be one group, two groups, -5, so 5 minus 2. So everyone in a group can settle their score when what? Well, you pay me, I pay this, and okay, so let's say that what is the maximum number of subgroups we can split this into? I don't know, bro. I cannot figure this out. Let's read this. Okay. Positive balance. Okay, I mean that's obvious. Zero transactions, so it's n minus the number of people involved, I guess. Or no. traverse. It's for all my days. I'm not gonna do anything today. Recursively process the next person. In other words, what? Define a recursive function to clear all balances in range 0 to current. It's the same, absolutely same code, bro. Current n. Next is valid recipient. Do the following: add current balance to next, call this and remove his balance. What? Okay. We can divide n persons into m groups, then it only takes n minus m transactions because each group will subtract 1 from the amount needed. That's fair because you need n minus 1 to resolve that. So the last guy doesn't have to send anyone anything. Fair enough. Okay. Okay, we remove one person from the current group at a time and recursively find the optimal solution for that subgroup. Hence we need to, for each of these subproblems, means that is not zero. Non-zero part of the plus the balance the optimal solution to its maximum optimal solution to its up. However, this property does not hold. Oh, okay, but how do we iterate over the masks? That's interesting. So okay, so let's say we have one giant group. Let's do it like that. So let's say we have one giant group. And now if the debt in this group is not zero, If the sum of balances of total mask is 0, return answer plus 1. So they say that if I remove that guy, then we need to do one more operation to resolve this. Not 0. Therefore, the non-zero part of the subproblem is the maximum optimal to its subproblem plus 1. Why? Well, the answer to each subproblem. But this is not even resolvable, bruh. What are you yapping about? I don't understand this, bro. This is crazy. I really need I, to be honest. Not really. If mask this is the case, then we can remove it. So DFS group balance plus equals want. So if he has less than if he wants less than he has, then he is in a negative. So I guess so with DFS mask XOR 1 to I, and then return if group balance ans plus equals 1 return ans, return DFS 1 to n minus this 1 to n minus 1, I guess, and then I add some LRU cache. The computer is lagging so bad. I'm always off by 1. Interesting. I cannot make sense of this. Why, if I have a group of 3 minus 3 1 minus 1, I just throw out the guy and suddenly the other group takes 1? What? Or you just pretend that I settled these guys, like if this is a sum of the last guy is not gonna settle it. So in one transaction they do this. Who cares? Okay. Whatever. Bit mask DP. If let's store net balance of each person, positive if they lend more money than they got, and negative if they got more than they lend. Sum of net balances is 0. If there is a subgroup of the people with a net balance of 0, their debts can be resolved. So we want to split the people into groups of into maximum number of groups with sum 0. A group of size let's start with a group of people containing all people. A group containing all people. If let's resolve one person's debt, and try to resolve the rest of the people debts. If the entire group had sum of balance is 0, we have to do, I cannot explain this. To resolve debts in a group of n people, we need n-1 transactions. So to minimize the number of transactions, the total number of transactions, we want to maximize the number of the groups to resolve debts in a group of n people. We need, so if there are m groups, we will need n-m transactions to resolve all debts. Let's start with one group of people and try to then remove a person from it and resolve the debts of the remaining people. let's say we can do that in T transactions. Let's let max let T max be the largest T when we try to remove all people from the group. Group has a total balance of 0. The number of transactions to resolve debts in that group will be Tmax plus 1, else it will be Tmax. O of n c dot 2 to n, since for each mask of people of which there are O of 2n, we do O of n work. O of n, since we have to store the net balances of each person. I have no clue how this works, and I hate it. Goodbye.